Hello students, in today's lesson we are going to learn about electrochemical series and electrochemistry. Right, so before we go into electrochemical series, we have to have an idea about electrode and standard electrode potential. So as you can see here in the diagram, in the left side you can see here we have the standard hydrogen electrode, and in the right side we have the zinc electrode. So why we call it as standard electrode potential? Because we here use the standard conditions, temperature 25 degrees Celsius, that is 298 Kelvin, and the pressure is 1 atmospheric pressure, and the solutions we use, the concentrations are 1 mole decimeter minus 3. So here standard electrode potential means here we use the zinc electrode as the test electrode. Here reference electrode is the hydrogen electrode. So hydrogen electrode, the potential value of this standard hydrogen electrode is considered 0 compared to this zinc electrode. So here we have the high resistance voltmeter. So it measures the electrode potential. That means the potential difference between these two electrons. Why it is high resistance voltmeter? To make the current flow 0, so we can measure the maximum voltage or the potential difference between the standard hydrogen electrode and the zinc electrode here. So that's how we record the value of standard electrode potential. That means here standard electrode potential of zinc. So if we want to measure the different standard electrode potentials for different metals, we have to replace this zinc electrode with that particular metal. For example, let's say we have to find out the standard electrode potential of copper, then we replace this zinc electrode with copper, and replace this solution with copper 2 plus solution. So that's how we find out the different standard electrode potential values for all the elements. Okay, so using that method, 0 here, and then you can see it slowly increases. So at the bottom it is more positive, right? So you can think it like a number line. Let's say if we so you can think it like the number line. If we turn here, let's say, okay, yeah, so from you can see here in the number line it's more negative, and it goes up to 0, and then it becomes it goes to more positive. So if we turn this, if we turn this into 90 degrees Celsius, sorry, if we turn 90 degrees, you can see it's the same trend like that. Right? So at the top of the series it is more negative. For example, for lithium it is minus 3.05, right? And it is becoming less negative. For example, for lead it is minus 0.13. For hydrogen it is 0, but because it is the reference electrode, and it is slowly increasing. For example, for silver it is plus 0.22, and it is increasing, and at the bottom it is becoming plus 2.87. So this trend you should be able to remember, that is at the top more negative and becoming less negative, 0, less positive, and then more positive, right? Okay, so we have to talk about the trend of oxidizing and reducing ability across the electrochemical series. So before going into that, we have to know about some terms, so that is not unfamiliar terms. Okay, let's see. Oxidation and reduction. So as you can see in this diagram or in this slide, I have say oxidation is loss of electrons, reduction is gaining of electrons. So in order to remember easily, we have an acronym OIL. You can say OIL, that is oxidation is loss, and for reduction it is RIG, that is reduction is gaining, right? Okay, so what is oxidizing agent then? Oxidizing agent means it oxidizes another species, that means, and they undergo reduction. As you know, oxidation and reduction reactions takes place simultaneously. That means when one species undergo oxidation, the other species undergo reduction. So in oxidizing agent, we say it oxidizes the other species. That means the other species undergo oxidation. That means this oxidizing agent, they have to undergo reduction. That means the gaining of electrons takes place here, right? And if we talk about reducing agent, that means it reduces the other species. That means they undergo oxidation where loss of electrons come into play, right? So again, if we go back to our electrochemical series, okay, so in the electrochemical series you can see the values here on top. At the very top we have more negative values. That means as we discussed in earlier videos, we know that negative values come from the electron density of the electrode. So electron density, where electron density high is where the more negative value come from standard reduction potential, right? So why electron density is high? Because those metals, they tend to lose electrons readily, right? So that means loss of electrons. So from the acronym we know it is OIL. OIL means oxidation is loss. So these species on top of the series, they undergo oxidation. That means they act as reducing agents. Those are very strong reducing agents, right? And when we go down this electrochemical series, the reducing ability decreases. So reducing ability means to act as reducing agent, the ability to act as reducing agent, right? You don't want to confuse with the reduction ability, right? Reduction ability is different from reducing ability. Reducing ability means to act as reducing agent. Reduction ability means they undergo reduction. That means they act as oxidizing agent, right? Okay, so when we think about the oxidizing ability, right, it increases down the series. Why I say like that? So oxidizing ability means to act as oxidizing agent. If they have to act as oxidizing agent, they have to undergo reduction. So when we go down the series, the reduction ability increases. That means they undergo reduction easily when we go down the series, right? So that means they can act as oxidizing agent easily. So in the electrochemical series, if we talk about or if we compare the trend, the reducing ability okay, right? Reducing ability decreases down the group, right? Reducing ability decreases down the series. And if we think about the oxidizing ability, it surely increases, right? Okay, so that's what I wanted to say about the oxidizing ability and reducing ability across the electrochemical series. Right, now let's look at the position of equilibrium depending on the electrode potential value. So you can see here we have put in two equilibrias, right? First one is the magnesium electrode and the second one is the copper electrode, right? Okay, so you know when we write equilibrium, electrode potential equilibrium, we write always as reduction potentials. That means always the gaining of electron comes to left side, right? Okay, so now let's compare the value of this electrode potentials. So you can see here magnesium, their standard reduction potential values minus 2.36, and in copper it is plus 0.34. That means here they have the ability to act as reducing agent. That means they have more negative values that act as anode, right? More negative value mean the electron density is high. That means they tend to undergo oxidation, right? That means they are good reducing agent, right? So in terms of position of equilibrium, we can say magnesium, they always try to undergo oxidation. That means their position of equilibrium is more to the left, right? But with copper, in the case of copper, comparatively they are less into that left side. So we say when we compare two electrodes, or let's say half cells, right, depending on their electrode potential values, we can say who is more to the left or in the equilibrium, right? If the electrode potential value is more negative, that means they are more to left, right? Okay, so that's all I wanted to discuss under this video. So let's meet in our next video. Thank you for watching.